Question 1. Find the integral of x to the power of a half times 2x minus 5 all over 3 with respect to x, writing each term in its simplest form. So we want to get rid of this over 3, so we can just change divide by 3 to times by a third. So I'm just going to rewrite it with the third in the front. So a third times x to the power of a half times 2x minus 5 with respect to x. Then I want to expand the brackets before I integrate. So a third x to the power of a half times 2x. So a third times 2 is 2/3. And x to the power of a half times another x. A half plus 1 is 1.5, or 3/2. A third x to the power of a half times negative 5 is 5 times a third. So 5/3. So negative 5/3 x to the power of a half with respect to x. Now it's in the perfect form for us to integrate it. So we're going to be adding 1 to the power and then dividing by the new power. So add 1 to the power. We have 3/2. Add 1 to it. It becomes 5/2, 5 halves. And then divide by the new power. What I'll do this in 2 steps. So I'm dividing by 5/2, and I'll do that in a minute. Same with the next one. I'll leave 5/3 there for now. I'll add 1 to the power, which become 3/2. Then I'm going to divide by the new power, and I will be plussing c on the end. When we're integrating, we're plussing c. Then I just need to divide by these fractions. Dividing by 5/2 is the same as multiplying by 2/5. So 2/5 times 2/3 will be 4. 2 times 2 is 4. 3 times 5 is 15. So 4/15 x to the power of 5/2. 5/3 times 2/3. So 5 times 2 and 3 times 3. And that is our final answer. Question 2. f of x is 4x cubed plus 5x squared minus 10x plus 4a. A is a positive constant. Given that x minus a is a factor of f of x, show that this. So get to this answer. So if x minus a is a factor, that means f of a must be equal to 0. So if x minus 2 is a factor, f of 2 equals 0. So f of a is equal to 0. So let's just write this out. So f of a is 4 times a cubed plus 5 times a squared minus 10a plus 4a, and it's equal to 0. So collect the like terms. 4a cubed plus 5a squared minus 6a equals 0. And we can see we just need to factorize out an a to finish this off. So let's take a outside. That's a times 4a squared plus 5a minus 6 equals 0 as requested. Hence, find the value of a. So we're going to solve. So either a equals 0 or 4a squared plus 5a minus 6 is equal to 0. Let's use a calculator. So let's grab our calculator, and then we will solve a quadratic using the calculator. So it's 4a squared plus 5a minus 6. So we've got 3/4 or -2. So a is 3/4 or a is -2. So a can be 0, 3/4 or -2, but we know a must be a positive constant. So we're finding the value, not values of a. So a must be 3/4. It must be 3/4 because it's a positive constant. So a equals 3/4 as a is a positive constant. Use algebra to find the exact solutions of the equation. So we know what a is. So all we need to do is substitute 3/4 in for 3/4 in for our a. And then we can solve f of x equals 3. So we've got 4x cubed plus 5x squared. So that's bi, I. So we've got 4x cubed plus 5x squared minus 10x plus 4 times 3/4. That's f of x, and it's equal to 3. 3/4 of 4 is 3 as well. So we've got 4x cubed plus 5x squared minus 10x plus 3 equals 3. And we can take 3 away from both sides. So we've got 4x cubed plus 5x squared minus 10x equals 0. So we can take x outside. So x times 4x squared plus 5x minus 10 equals 0. And then we're solving the exact solutions. So all the solutions, I think. So x equals 0. And then again, grab the calculator. So it's 4x squared plus 5x minus 10. And we want the exact solution. So -5 plus root 185 over 8 and -5 minus root 185 over 8. Question 3. Relative to a fixed origin O, the point A has position vector 5i plus 3j plus 2k. Point B has position vector 2i plus 4j plus ak, where a is a positive integer. Show that O to A, the modulus of the distance, so the distance between O and A, is root 38. So to find the distance from O to A, so it's 5 in the I direction, 3 in the j direction, and 2 in the k direction. It is just the square root of 5 squared plus 3 squared plus 2 squared. So the square root of 5 squared plus 3 squared plus 2 squared is square root 38. Part B, find the smallest value of A for which O to B is greater than O to A. So O to B is 2 squared plus 4 squared plus A squared, and it's got to be greater than square root 38. So if we square both sides, we will get 2 squared plus 4 squared plus A squared is bigger than 38. 2 squared plus 4 squared is 20. So take away 20 from both sides. A squared has got to be bigger than 18. So what's the smallest value of A? A is a positive integer. So to be bigger than 18, the smallest thing it can be is a 5. 4 squared is 16, which is less than 18. 5 squared is 25, which is bigger than 18. Question 4. The curve C has equation y equals f of x. And given that f dash x, f prime x, the gradient function, is 2x plus half cos x. The curve has a stationary point with x coordinate alpha. So at a stationary point, the gradient function is equal to 0. So we can say f dash alpha equals 0. And alpha is small, so we can use the small angle approximation. Part A says use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. So the small angle approximation for cos x is in our formula book. It says cos alpha is approximately equal to 1 minus cos theta is approximately equal to 1 minus theta squared over 2. So let's use that. So part A. So we know that 2 alpha plus half cos alpha is equal to 0. The gradient function equals 0. And then use the small angle approximation. So for cos alpha, we're going to write 1 minus alpha squared over 2. So 2 alpha plus half times 1 minus alpha squared over 2. Then let's expand this bracket. 2 alpha plus a half minus alpha squared over 4. Then we have a quadratic. I'll write it in order. So it's minus a quarter alpha squared plus 2 alpha plus a half equals 0. And I'm just going to type this into my calculator to solve the quadratic. So polynomial degree 2, I've got minus a quarter x plus 2x plus a half. And I've got either 8.24 or negative 0.243. So we've got two answers, but we know that it's got to be small. So 8.24 is no good to us. It's not small. So we know theta must be negative 0.243. The point P, 0,3, lies on C. Find the equation of the tangent to the curve at P. So we've got the gradient function. We can find the gradient from the gradient function, given your answer in the form y equals mx plus c. So the gradient function is 2x plus half cos x. And it's the point 0,3. So it's got an x coordinate of 0. So the gradient is going to be 2 zeros plus half times cos 0. Cos 0 is 1. So 2 zeros plus half times 1 is a half. So the gradients are half, the y-intercept's at 3, so we've got y equals half x plus 3. Question 5. A continuous curve has equation y equals f of x. The table shows corresponding values of x and y for this curve, where a and b are constants. So a and b missing numbers here. The trapezium rule is used with all the values in the table to find an approximate area under the curve between 3 and 4. Given that this area is 17.59, show that a plus 2b equals 51. So we're going to use the trapezium rule with our two missing numbers in it, and then we should be able to get to a plus 2b equals 51. I use a slightly different version of the trapezium rule. So we have a gap here, which is 0.2. It's going up by 0.2 every time. So 0.2 times, and I'm going to half the first and the last. So a over 2 plus 16.8 plus b plus 20.2 plus 18.7 plus 13.5 over 2. So 0.2, the gap between them, times all of them added together with the first and the last halved. Then if I simplify this, and it equals 17.59. If I simplify this, I should be able to get a plus 2b equals 51. So let's get rid of the 0.2. Get rid of the 0.2 first. So times both sides by 5 or divide both sides by 0.2. So 17.59. 17.59 times 5 is 87.95. 87.95. So that gets rid of the 0.2, and let's add up what we know. So we've got 16.8 plus 20.2 plus 18.7 plus 13.5 over 2. And that is 62.45. So a over 2 plus b plus 62.45 equals 87.95. 87.95 take away answer is 51 over 2. So a over 2 plus b equals 51 over 2, and then double everything. A plus 2b equals 51. That's part A done. Given also that the sum of all the y values in the table is 97.2, find the value of a and the value of b. So the sum of all of them is 97.2. So we've got a and b. We've also got 16.8, 20.2, 18.7, and 13.5. So 69.2. So a plus b plus 69.2 equals 97.2. So 97.2, takeaway answer is 28. So a plus b must equal 28. And then we just need to solve these simultaneous equations. So we've also got a plus 2b equals 51. It's in the right form to just use the calculator. So we've got 1a and 1b is 28. And 1a and 2b's are 51. So a is 5 and b is 23. Question 6. A equals log 2x. B equals log 2x plus 8. Express in terms of A and or B. So part A, log base 2, square root x. So when we have square root x, we can change it to x to the power of a half. So we've got log base 2, x to the power of a half. And when we've got a power on our big number, on our argument, we can bring it to the front. So it's half log 2x. And log 2x is a, so it's half a. Part B, we've got log base 2, x squared plus 8x. X squared plus 8x is the same as x times x plus 8. And when we've got two things multiplied together, we can change them to an add. So we can have log 2x plus log 2x plus 8. So we can split it up into two separate logs with a plus in between them. Two things multiplied together, split them up into a plus, two things plus together. Log 2x, that was a, and log 2x plus 8, that was b. So we've got a plus b. And finally, we've got log 2, 8 plus 64 over x. So let's try and add these together. So to add them together, we want the denominators to be the same. So let's make it times top and bottom of the 8 by x. So log base 2, 8x over x plus 64 over x, which is log base 2, 8x plus 64 over x. When we've got a divide, we can change it into a minus. So we've got log base 2, 8x plus 64 minus log 2x. And if we factorize out the 8, so we've got log 2, 8 times x plus 8 minus log 2x. So that's log 2, 8 plus log 2x plus 8 minus log 2x. Log 2, 8. So 2 to the power of what is equal to 8? That's 3. Log 2x plus 8, we can change into b. And log 2x, we can change into a. Question 7. The function f is defined by f of x equals 3 plus the square root of x minus 2, where x is from the set of real numbers and x is greater than 2. State the range of f. So if our input, our domain, is x is greater than 2, this square root part, if we put in 2, it would be 0, but we can't put in 2, it's got to be greater than 0. So it's going to be anything bigger than 0, this square root part. It can be anything bigger than 0. So in total, f of x is going to be 3 plus anything bigger than 0. So anything greater than 3. So f of x is going to have to be bigger than 3. Find f minus 1, our inverse function. Found our inverse function, the function that does the opposite thing to f of x. So I'm going to rewrite it as y equals. And then I'm going to rearrange it to make x the subject. And from there, we'll be able to see what the inverse function is. So I'm going to take 3 away from both sides. Square both sides. And then add 2 onto both sides. So x equals y minus 3 squared plus 2. When we have an inverse function, the domain becomes the range becomes the domain, the input becomes the output becomes the input. So the x and y switch around. So our inverse function is x minus 3 squared plus 2. That's our inverse function. And remember, the domain becomes the range becomes the domain. So our output for the original function was f of x is bigger than 3. So for this function, x is going to have to be bigger than 3. We have a function g. G of x is 15 over x minus 3, where x cannot equal 3. Gf of 6, we want to find gf of 6, so we're going to put 6 into f, and we're going to put that into g. So our f function was 3 plus the square root of x minus 2. And we're putting 6 into it. So 3 minus the square root of 6 minus 2. 3 plus the square root of 6 minus 2. So 6 minus 2 is 4. So square root 4 is 2. 3 plus 2 is 5. So f of 6 is 5. And then we're going to put 5 into our g function. So g of 5 is 15 over 5 minus 3. G of 5 equals 15 over 5 minus 3, which is 15 over 2. So that's part C. Part D, find the exact value of the constant a for which f of a squared plus 2 equals g of a. So f of a squared plus 2 is going to be 3 plus the square root. So in for x, we're putting a squared plus 2. A squared plus 2 minus 2. And that is going to be equal to g of a. G of a is 15 over a minus 3. So let's pick this up. And drag it down. So this is what we have to solve. So our plus 2 minus 2 is going to cancel out. So we're going to have 3 plus the square root of a squared equals 15 over a minus 3. The square root of a squared, that's a. So that's a plus 3. To get rid of the fraction, we're going to times by a minus 3. So we've got a plus 3 times a minus 3 equals 15. So a squared minus 9 equals 15. Plus 9 to both sides. And square root. I'll put plus or minus square root. So a can be plus or minus square root 24. But we're looking for an exact value, not values. And well, x is going to have to be bigger than 2. So a has to be bigger than 2. Therefore, a equals square root 24, not the negative square root of 24. If we tried to put the negative square root 24 in negative square root 24, they wouldn't be equal anyway, because negative square root 24 would give a positive on this side and a negative on that side. So it's not necessarily because of that, they just wouldn't be equal. So reject negative square root 24. A is square root 24, and we can simplify that. It's root 6 times root 4, so it's 2 root 6s. Question 8. Figure A, figure 1, shows the plan view of a stage. The plan view shows 2 congruent triangles, so identical triangles, joined to a sector. Angle COE is 2.3 radians. So we can work out these 2 angles here because they're going to be identical. So it's going to be, each one is going to be pi, take away 2.3. So angles in a straight line add up to 180 degrees, or pi. So pi take away that, divided by 2. So that's both of those angles. Arc length CDE, 27.6. AOG is a straight line of 15. So again, because they're congruent, it's going to be 7.5 meters on both sides. Show that O to C is 12. So that's the radius. So our radius is O to C. So show that it's 12. So we're in radians. So the arc length is r times theta. And the arc length is 27.6 equals r times theta, which is 2.3. So r is 27.6 divided by 2.3, which is 12. Show that the size of angle AOB is 0.421 radians to 3 significant figures. AOB, so that's this angle here, so it's pi, take away 2.3 over 2. So just type it into the calculator. And we get 0.421. That's what we wanted. Just going to change my calculator into radians for when I need it. Given that the total length of the front of the stage is 35 meters, the total length of the front of the stage, so I'm guessing that means adding on these 2 parts. So 2x's plus 27.6 equal 35. Equal 35. So 2x's plus 27.6 equal 35. So take away the 27.6, divide by 2, so we get 3.7s. So x is 3.7. So this one's 3.7 here. So we can find that total length, and then we'll be able to, we'll have all the information we need because we can find the area of the triangle using half AB sine C. So let's find O to B, the total length O to B is going to be O to C plus X. So O to B is O to C plus X, which is 12 plus 3.7, which is 15.7. So for our triangle, we've got 15.7, 7.5, and 0.421. So 15.7, we've got, it was 7.5 and 0.421. That's our triangle. And our sector, it was, the radius was 12 and it was 2.3 radians. So we've got to work out the area of two triangles plus a sector, and that will be our total area. So we've got half AB sine C, well, we've got two lots of them. So the triangle's area is two lots of half AB sine C. So two halves I'm going to cancel out. So 7.5 times 15.7 sine 0.421, 48.12. And the sector area, we're in radians, so it's half r squared theta. So half times 12 squared times 2.3. Which is 165.6. So add them together. So I saved my answer, my 48.12 as A. I just add on the A. I get 213.7 to the nearest square meter. So that would be 214. Question 9. The first three terms of a geometric sequence are 3k plus 4, 12 minus 3k, and k plus 16, where k is a constant. Show that k satisfies the equation. So we're going to get to 3k squared minus 62k plus 40 equals 0. So if it's a geometric sequence, that means it's got a common ratio. So the thing you times by to get from one term to the next term will always be the same. So that means 12 minus 3k over, so 12 minus 3k over 3k plus 4 will be equal to the common ratio. So dividing the second term by the first term will get us the common ratio, and that's going to be equal to the third term, k plus 16, divided by the second term, which should also be the common ratio. So now we can simplify this, and it should get us to the 3k squared and so on. So times both sides by both of the denominators. So that will be 12 minus 3k times 12 minus 3k equals k plus 16 times 3k plus 4. Then we're just going to expand and simplify, which will get us to 144 minus 36k minus another 36k, which would be 72k plus 9k squared. And that was equal to 3k squared plus 4k plus 3 16ths, 48k plus 4 16ths, 64. And then we'll make it equal to 0. So take 3k squared away from both sides, which is 6k squareds. We will take 52k away from both sides. So that would be 72, take away 52, will be 124. And take 64 away from both sides, which will be 80. And then we'll just half everything. And we get what we wanted. Part B, given the sequence converges. So if for the sequence to converge, R, the common ratio, has to be less than 1 or between -1 and 1. We need to find the value of k. So we can just use the calculator, solve the quadratic. So it's 3k squared minus 62k plus 40. So we've got 20 or 2/3. K equals 20 or 2/3. And we want the common ratio to be between -1 and 1. So the value of k isn't the common ratio. So if it was 20, we'll have, if k is 20, the terms of the sequence will be 3 20s plus 4, so 64. 12 minus 3 20s. -48. And k plus 16, 36. So that looks like it's going to converge. And if k was 2/3, our sequence would be 2/3 times 3 is 2, plus 4 is 6. 12 minus 2 is 10. And 16 and 2/3. So that is a common ratio bigger than 1. That's diverging. -48. Let's work out the common ratio. -48 over 64. Is -3/4. And 10 over 6 is 5/3. So that tells us in order to converge, k equals 20 because r is between -1 and 1. Therefore, r equals -3/4. Find the value of the sum to infinity. So the sum to infinity is a over 1 minus r. A, the first term, is 64. And 1 minus r, r is -3/4. So 1 minus -3/4. A over 1 minus r, 256/7. Question 10. A circle C has equation x squared plus y squared plus 6kx minus 2ky plus 7 equals 0, where k is a constant. We need to find in terms of k the coordinates of the centre and the radius. So we're going to rewrite it into the form x minus a squared plus y minus b squared equals the radius squared. So we're rewriting it. Let's get the x's together and the y's together. So x squared plus 6kx plus y squared minus 2ky plus 7 equals 0. And then we're going to complete the square on the x's and complete the square on the y's. So I have x halving 6k, so we get 3k. So x plus 3k squared, take away our 3k squared, which is 9k squared. Then the same for the y's. Y minus half of minus 2k is minus 1k. And then k squared is k squared plus 7 equals 0. Then just moving all of our constants over to the other side. So I've got x plus 3k squared plus y minus k squared equals, I've got 10k squared minus 7. So it's in the form x minus a squared plus y minus b squared equals r squared. So now we can just write down the centre and the radius. So the centre is what makes the first bracket 0. X have to be minus 3k. What makes the second bracket 0? That's k. And the radius is going to be the square root of r squared. So the square root of 10k squared minus 7. The line with equation y equals 2x minus 1 intersects at two distinct points. So we've got 2 points of intersection. That means the simultaneous equations have got two solutions. So if we solve this simultaneously, so our two equations, either our rearranged one, but probably better our original one. So our two simultaneous equations, we'll solve them. So we can substitute 2x minus 1 in for y in our original. And then it will leave us a quadratic. And we can use the discriminant because two solutions means b squared minus 4ac is going to be bigger than 0. So let's substitute 2x minus 1 in for y. So we've got x squared plus 6kx. And wherever we have y, we're changing it to 2x minus 1. Not 2k, 2x. 2x minus 1 squared minus 2k times 2x minus 1 plus 7 equals 0. So we'll expand all these brackets. and simplify. So 2x minus 1 times 2x minus 1. 4x squared minus 2x plus 1 minus 4kx plus 2k plus 7 equals 0. So we have x squared terms, we have x terms, and we have our numbers by themselves. So collect the like terms. We have 5x squareds. We have 2kx minus 4x plus 2kx minus 4x, which we should change into 2k minus 4x. Then we've got 2k plus 8, which we can just write as 2k plus 8. So that's our equation. And we know it's got two solutions. So b squared minus 4ac has to be positive. So that is 2k minus 4 squared minus 4 times 5 times 2k plus 8 has to be bigger than 0. So 4k squared minus 16k plus 16 minus 20 times 2k, so minus 40k minus 20 times 8 minus 160 is bigger than 0. So 4k squared minus 56k minus 144 is bigger than 0. So we've got a quadratic. Let's just use the calculator to solve it. Bigger than 0. So it's 4k squared minus 56k minus 144. So k is less than 7 minus root 85, or bigger than 7 plus root 85. So k is less than 7 minus root 85, or k is bigger than 7 plus root 85. Question 11. The value v pounds of a mobile phone t months after it was bought is modelled by v equals a b to the power of t, where a and b are constants. Figure 2 shows the linear relationship between log 10v and t. The line passes through 0, 3 and 10, 2.79. Using these points, find the initial value of the phone. So the initial value of the phone is when t equals 0. So it's 0, 3, but this is log 10v. So log 10v equals 3. Log 10v equals 3. So we can take it out of log form. So v is our answer, and that's 10 cubed. 10 cubed, which is 1,000. So it is, the initial value of the phone is £1,000. Find the complete equation for v in terms of t, giving the exact value of a and giving the value of b to 3 significant figures. So we're going to get something in the form v equals a, b, t, and we can use our straight line that we've been given here. So y equals mx plus c, but instead of y we've got log 10v, so it's log 10v equals mt plus c. And we know c is 3, so we just need to work out the gradient. So the gradient is the change in y, 2.79 minus 3, over the change in x, 10 minus 0. So we have 2.79 minus 3 over 10, which is minus 0.021. So our straight line is y equals mx plus c, and the y-intercept was at 3. So taking it out of log form, we'll have v equals 10 to the power of 0.021t plus 3. And I can split this up. So when we've added the powers, that means we've multiplied two indices. So 10 cubed times 10 to the power of 0.021t. So 1,000 times 10 to the power of 0.021 to the power of t. So our A is 1,000, we already knew that. Our B is 10 to the power of 0.021, 0.953. So it's 1,000 times 0.953 to the power of t. So that's part B. Part C, exactly 2 years after it was bought, the value of the phone is £320. Use this information to evaluate the reliability of the model. So T is the number of months after it was bought. So 2 years is 24 months. So when T equals 24, what does the model think the value should be? So 1,000 times 0.953 to the power of 24 is £315. So comment on the reliability of the model. So 315 is close to 320, therefore it seems reliable. So 315 is close to 320, therefore the model seems to be reliable. Question 12. Y equals sine x, where x is measured in radians. Use differentiation from first principles to show that dy dx equals cos x, and we may use, without proof, the formula of sine a plus or minus b, and assume that as h approaches 0, sine h over h goes to 1, and cos h minus 1 over h goes to 0. So differentiation from first principles, it's given to us in our formula book as f dash of x equals f of x plus h minus f of x over h. So we can just substitute into this, and I've missed out the limit as h approaches 0, so I'll slide that across. The limit as h approaches 0 of f of x plus h minus f of x all over h. Let's just substitute in now. So we want the limit as h approaches 0 of f of x plus h, which is sine x plus h, minus f of x, which is sine x, all over h. Now we can use, as we've been told, sine A plus B for this part. And sine A plus B is sine A cos B plus cos A sine B. Again, in our formula book, if we want to use it. So we've got the limit as h gets closer to 0 of sine x cos h plus cos x sine h minus sine x over h. And then we're also using sine h over h and cos h minus 1 over h and their limits. So we're going to get it into the right form for that. So we want a sine h over h and a cos h minus 1 over h. So if we get our sine x's together, sine x cos h minus sine x, and then we'll factorize out the sine x, and we'll get our cos by itself. And we can factorize out that as well. So the limit as h approaches 0 of sine x times, so factorizing out the sine x leaves cos h minus 1, and factorizing out the cos x just leaves sine h over h. So as h approaches 0, what happens? So cos h minus 1 over h goes to 0. So we have sine x times 0 plus cos x times sine h over h goes to 1 times 1. So sine x times 0 is going to be 0. Cos x times 1 is cos x. So that is our answer. Question 13. On a roller coaster ride, passengers travel in carriages around the track. On the ride, carriages complete multiple circuits of the track, such that the maximum vertical height of the carriage above the ground is 60 meters. A carriage starts a circuit at a vertical height of 2 meters above the ground. The ground is horizontal. The vertical height of a carriage above the ground, t seconds after the carriage starts the first circuit, is modeled by the equation. So h equals a minus b times t minus 20 squared, where a and b are positive constants. Find the complete equation for the model. So find the values of a and b. So here we've got a quadratic, and the maximum height is going to be where the bracket equals 0. It's in the complete the square form. So maximum height is when t equals 20. Max height when t equals 20. And that will be 0 times b, which will be 0. So the height will be a, and that will be 60. So therefore, a will be 60. We also know that it starts at 2. So when t is 0, h equals 2. When t equals 0, h equals 2. So we have 2 equals a, which is 60, 60 minus b, times when t is 0, so negative 20 squared. So negative 20 squared, let's take 60 away. So 2 minus 60 will be negative 58. So negative 58 equals negative b times negative 20 squared, which is 400. So b is going to be 58 over 400, which is 0.145. So our complete model is h equals 60 minus 0.145 times t minus 20 squared. Use the model to determine the height when t equals 40. So when t is equal to 40, what do we have? We have 60 minus 0.145 times 40 minus 20 squared. Which is 2. Meters. In an alternative model, the vertical height, h meters, of a carriage above the ground, t seconds after the carriage starts the first circuit is given by, so we've got a different one, h equals 29 cos 9t plus alpha plus beta, where alpha and beta are constants. Find the complete equation for the alternative model. So this time we've still got the same information, so the maximum is 60 and it starts at 2. So the maximum is 60. The biggest thing the cos can be is 1. So beta must be 31. So we've got h equals 29 cos 9t plus alpha plus 31. And then we can find alpha because at the start, h is 2. So when t equals 0, h equals 2. So 2 is 29 times cos alpha plus 31. So let's just find alpha. So 2 minus 31 is going to be negative 29. Over 29 is negative 1. And shift cos negative 1 is going to be pi. It's in degrees. So 180. 180, yep, alpha's between 0 and 360. So we'll have 180 degrees. Let's put in a line of working out there. So negative 29 over 29 equals cos alpha. Alpha is 180. And the complete model is h equals 29 cos 9t plus 180 plus 31. Given that the carriage moves continuously for 2 minutes, give a reason why the alternative model would be more appropriate. So with our original model, we've got a quadratic. It's a negative quadratic. So it started at 2. It went up. And then it's going to go back down. It was back at 2 at 40 after 40 seconds. Then it's going to keep going down and down and down into the ground. So that's not what we want. We don't want it to make this shape. It would be better if it makes our wavy shape so 29 cos 90. So this one is going to go between 2 and 60, and it will keep going like a wave. So the alternative model will repeat. So it's going to follow this wavy pattern. So it starts at 2, and that's its minimum. So it goes like this. But the original will keep going down like so. Question 14. Prove using algebra that n plus 1 cubed minus n cubed is odd for all natural numbers, so all positive integers, and we can just do even and odd. So we can look if it's even. Is it odd? If n is even, we get an odd result. If n is odd, we get an odd result. Therefore, we have proved it. So if n is even, we can say that n is a multiple of 2, so 2m. So if n is even, we have 2m plus 1 cubed minus 2m cubed. And we're going to have to do the expansions here. So it's 2m plus 1 times 2m plus 1 times 2m plus 1 minus 2m times 2m times 2m, which is 8m cubed. I'm going to expand the first two brackets and then multiply by the third bracket. So I've got 4m squared plus 2m plus 1, which is 8m cubed plus 4m squared plus 8m squared plus 4m plus 2m plus 1 minus 8m cubed. So my m cubeds cancel out. I've got 12m squareds plus 6m plus 1. So 12m squared plus 6m plus 1. And that is odd because my first two terms are even, and an even plus 1 is odd. So even plus 1 is odd. So that's odd. Then if n is odd, that's the other option. If n is odd, we can let n equal 2m plus 1. So an even number plus 1 is an odd number. So I'm going to have 2m plus 1 cubed minus 2m plus 1 cubed. I've just done the expansion of 2m plus 1 cubed, so I don't have to repeat that. But I'm going to have to do this expansion. So 2m plus 1 cubed was 8m cubed plus 12m squared plus 6m plus 1. I'm going to have to do the first expansion. So 2m plus 2 times 2m plus 2 times 2m plus 2. So I have 4m squared plus 4m plus 4m plus 4 times 2m plus 2. And I've multiplied all these by minus 1 in the second bracket to expand that bracket. So 8m cubed minus 12m squared minus 6m minus 1. And we have here 8m cubed plus 8m squared plus 16m squared plus 16m plus 8m plus 8. And then we just need to collect the like terms. So I've got my 8m cubes, they cancel out. So I've got 24m squared minus 12m squared, which is 12m squareds. I've got 24m, take away 6m, so 18m. And I've got 8 take away 1, which is 7. So again, this is odd. And I can even rewrite it as 12m squared plus 18m plus 6 plus 1. And show I've got an even number at the front. It's in the 2 times table, so it's even. And an even plus 1 is odd. Therefore, n plus 1 cubed minus n cubed is odd for all natural numbers. And I'll just repeat the notation, which was n is a set of natural numbers. Question 15. A curve has equation y equals f of x, where f of x is 7x ex over the square root of e3x minus 2. We need to show that f dash x, our gradient function, is equal to this, where a and b are constants to be found. So we are differentiating, and it's a fraction. We're going to use the quotient rule. So we're going to say that u is 7x ex, v is e3x minus 2 to the power of a half, and we're using the quotient rule, which is dy dx is v du dx minus u dv dx over v squared. So we're going to have to differentiate u and v using the product rule and the chain rule, and then put it all into our quotient rule. So let's start with finding du dx, and that is a product rule question. So we've got 7x times ex, so we're going to differentiate them both. 7x differentiated is 7, ex differentiated is ex, and the product rule says dy dx is v du dx plus u dv dx. So it's these two times together and these two times together with a plus in the middle. So du dx is 7ex plus 7x ex. dv dx So we're going to times by the power, take one off the power, and times by the bracket differentiated. E3x differentiated is 3e3x. And then half times 3 is 3 halves, 3 over 2. So we've got 3 over 2 e3x times e3x minus 2 to the power of minus a half. So now we know u, v, du dx, and dv dx. We can put them into the quotient rule. So our gradient function, f dash of x, is equal to v du dx. So v e3x minus 2 to the power of a half times du dx, which is 7ex plus 7x ex. So v du dx minus u 7x ex times dv dx, which is 3 over 2 e3x times e3x minus 2 to the power of minus a half, all over v squared, which is e3x minus 2. So it was square rooted. So when we square it, it just becomes the bracket, e3x minus 2. So that's the gradient function. It's not in the form we want. So we have to do a bit of simplifying here. That might be an understatement. So we've got to change the power. So times top and bottom by e3x minus 2 to the power of a half. And double the top and the bottom. So if we times, let's do the e3x to the power of a half first. So e3x minus 2 to the power of a half. So we're timesing both the terms on the top and the denominator. So this e3x minus 2 to the power of minus a half is going to get cancelled out. So something to the power of minus a half times something to the power of a half is the power of 0. So it's going to go e3x. So that's gone. And our denominator is now e3x minus 2 to the power of 3 over 2. We still need to double the top and the bottom. So let's have 2 times e3x minus 2. So still thinking of it as 2 terms, times 7ex plus 7x ex minus, I've got an over 2 here. I'm going to change that to just a 3. So I could write this as 21 over 2 and then double it. So it'd just be a 21. So 21 x ex times e3x. And now my denominator is what I wanted it to be. My numerator still isn't though. So we want probably to expand these brackets. I think, so for the numerator, we're factorizing out 7ex. Let's try and do that first. So 7ex comes out of this bracket. 7ex is there as well. So I'm going to take it out of this bracket here. 7ex is coming out of here. And I'm going to move it to the front, which is going to make it a 14ex. So 14ex. And I'm going to stick with this green bracket. So I've taken 7ex out, which leaves 1 plus x. Then it's times by this other bracket, e3x minus 2 minus 21x ex times e3x. Now I've got two terms, so I'm saying 1, 2 terms, and I'm taking 7ex out of both of them. So I shouldn't forget the denominator. So I'm going to take 7ex out, which leaves 2 times 1 plus x times e3x minus 2 as my blue term. And my green term is 3x. So I've taken 7ex out. So I've got 3x, e3x left over my denominator, which is what I want it to be. I'm still not where I need to be. So I need to expand these brackets. 7ex times, I'll leave the 2 for now, e3x minus 2 plus x e3x minus 2x minus 3x e3x. And again, the correct denominator. Simplifying again for my numerator. Need more space. So simplifying again, we have 7ex. I think I'm going to expand with the 2 now. So 2e3x minus 4 plus 2x e3x minus 4x minus 3x e3x. I've got 2x e3x minus 3x e3x. So I can, again, denominator. Collect these like terms. So 7ex times 2e3x minus xe3x minus 4x minus 4 over that denominator that hasn't changed. I think I'm there. I need e3x factorized out. So e3x comes out. So it's 7ex. e3x is out, leaving 2 minus x minus 4x minus 4 over 2e3x minus 2 to the power of 3 over 2. And that is finally what we wanted. Okay, part B. Hence show that the x coordinates of the turning points of the curve are solutions to the equation. So the turning points are where the gradient, which is what we've just worked out, equals 0. So this gradient that we just worked out is going to be equal to 0. For this to be 0, we can ignore the denominator. So times both sides by the denominator. Let's just get rid of it. That denominator we've copied down line after line is now just going. And we can also get rid of this 7ex, our exponential function. 7ex is that one can never equal 0. So that can go. So in order for this function to be equal to 0, it must be the e3x times 2 minus x minus 4x minus 4 part that's equal to 0. So we are trying to get to show that the x coordinates are solutions to the equation. So something in the form x equals is what we want. So let's expand this bracket. 2e3x minus x e3x minus 4x minus 4 equals 0. We want the x equals. Let's get the two x terms by themselves. So 2e3x minus 4 equals xe3x plus 4x. And then we can factorize the x out of those two terms. And then divide by what we need to divide by to get x by itself. So 2e3x minus 4 over e3x plus 4. So 2ex, what was that? So 2e3x minus 4 over e3x plus 4. Okay, so the equation, that equation has two positive roots, alpha and beta. Beta is greater than alpha, and it's becoming an iteration formula. And the student uses it. Diagram 1 shows part of the equation y equals, so y equals the right hand side and y equals x, so y equals the left hand side. So the solutions are going to be the intersections, and we're going to draw a staircase diagram starting with x equals 1 to show that it can be used to find beta. So a staircase diagram, x equals 1. So diagram 1 here. So 1 goes in, and when we substitute the 1 in, we substitute it into the right hand side. That's this one up here. I have to do it freehand because it's not lining up properly. That's not freehand, that's a straight line. But it goes into there. And then we get that answer out. Put it back in. Get that answer out. Put it back in. Get that answer out. Put it back in. And so on. So it gets closer and closer to beta, which is what we wanted, to find an approximation for beta. And then use the iteration formula, part D, with x1 equals 1 to find the 3 decimal places, x2 and beta, and the answer. So we're using the iteration formula now. So D part 1. So x1 equals 1. So we're substituting 1 into our iteration formula. So it's going to be, let's make 1 and make that the answer so we can use it over and over again. 2 times e to the power of 3 answers minus 4 over e to the power of 3 answers plus 4. So 1.502 x2 equals 1.502. And then if we keep doing that over and over again, so x3, 4, 5, 6, 7, 8, 9, and so on. So 1.968. 1.968. Using a suitable interval and a suitable function that should be stated, show that alpha, our other turning point, is 0.432 to 3 decimal places. So we're going to use the lower bound and the upper bound. So 0.4315 and 0.4325. So it's a turning point. So if we substitute them both into our gradient function, we should get one positive gradient, one negative gradient, and then that's how it's turned. So we're going to substitute both of these into our gradient function. So we need to state our gradient function. So our gradient function f dash of x is equal to, what is our gradient function? It's this. That is our gradient function. So we're going to substitute both in to that gradient function. So we're going to have f dash of 0.4315, f dash of 0.4325, and hopefully we'll get one positive and one negative. So it's just a case of substituting them in. So 7e to the power of 0.4315 times e to the power of 3 times 0.4315 times 2 minus x, 0.4315, close bracket, minus 4 0.4315s, minus 4, close bracket, over 2 times e to the power of 3 0.4315s, minus 2 to the power of 1.5. So I've got minus 5.789 times 10 to the power of negative 3, minus 5.789 times 10 to the power of negative 3, and 0.4325, I should just be able to change them as I go to a 2. And I get 0.0183. So I've got a negative and a positive. So I can write change of sign and continuous function. Therefore, alpha equals 0.432 to 3 decimal places.